You already started recording, Ben?
It looks like it. I am using my own account, so I can't control the recording, I don't think.
Okay.
Yeah, it says recording.
So you probably want to cut it afterwards.
Yeah, I don't know. Have people been doing that? If it's easy, I can do that for sure. Yeah. Hey, James. Hey, Craig.
Hello. Are you laughing at me, bro?
Just, you think of fingers as opaque, but they're partially translucent.
Indeed, they are. Gives you that
Hello.
nice orange glow.
Hey, guys. Okay. I guess we can get started since we have quite a few folks already. Let me share my screen here. All right.
If anyone's at Atmosphere and they want to come to the meeting room, I feel lonely here.
I can join you in a minute.
All right. Everyone can see the screen share?
I can.
Yep.
Okay. So I just put a bunch of things on the agenda for today, which have mainly been around what we've done recently, as well as what's going on right now. If there's anything else, please just feel free to put it down here. But we can go over these and talk about each one. How's that sound to people?
Sounds good.
Okay, so the first thing I wanted to talk about was there was this ticket, it was Mesa's 8418, which I think was filed in January. And unfortunately, we didn't really respond to it until Stephen Erb happened to mention something in Slack, and I asked him what he was talking about, and he mentioned this ticket, and I asked him to gather some performance data. So it's fixed now, but at the time it was something that kind of lagged behind pretty badly, given that this was leading to the agent utilization being really high when there were a lot of containers. So he said it's fixed for him, but I just realized that, probably before each meeting, I need to just do a quick audit of what tickets have been filed with the performance label, because this did actually have the performance label on it. So just in thinking about how to avoid this happening again, I'm probably gonna either in the meeting or before the meeting just go over those tickets and make sure that we're aware of them. It probably would have showed up in the dashboard actually that I have here. Somewhere here. Kanban. I guess it has to be, oops. I guess it doesn't show up here resolved because maybe we don't show those. I need to update the board, I guess, but it should have showed up in the backlog at least. Yeah. Anyway, that's just a little process thing that I guess I should start doing in order to avoid this kind of thing happening again. But the issue here was that when you request container metrics, all the C group reads of the stat files end up calling something that verifies that the C group is mounted in the hierarchy and so on, and that ends up needing to look at mounts, proc self mounts, which in his case was a huge file. It was like 200 kilobyte file, and that's because I believe that's because he was using overlay FS or something. But in any case, they're running a lot of containers as well. I think that Stephen was running 140, and the original ticket was 150. So I think this is maybe not something that a lot of users actually get up to, but we probably need to start benchmarking the agent's scalability on containers as well. Anyone else have any questions or comments about this ticket? No? Okay.
Sorry, what was the current status of it?
The current status, oh yeah, I should probably have mentioned that. The current status was I did like a low, I did a short-term fix, which just moves the verification in the read helper to be only after a read actually fails. So it directly goes and does the read, avoiding the verification. And if the read fails, it does verification to provide the better error message that verification was providing. So it doesn't break any tests or anything. But longer term, talking with G, I think we wanted to make the verification like a standalone thing that callers can use when they're, say, initializing, recovering. And so that fixed that part of the issue, but I think the original ticket filer mentioned that he was seeing an additional issue with stat FS, which is definitely a different problem. So I chatted with him on Slack as well, and he's on vacation right now, but when he gets back, he's gonna file a different ticket if he's still seeing that and give us some perf data for it.
DataFS should be fairly cheap unless we could be calling it like way too often, I guess.
Yeah. I was also wondering if maybe like overlay FS or something could affect that, like make it slower. I don't know.
Yeah, that seems like it could be.
I just looked at the StatFS page and saw like overlay FS strings in there, so I was like, okay, maybe that could affect it. Yeah, but that's the current status. Just waiting for him to. The original issue is fixed, and just waiting for him to come back on vacation and file another ticket if there's something else going on. Okay. The second piece, I don't know if so. I see Alex is on the call. I don't know if Alex, you want to talk about this or if.
Yeah, gladly.
Okay.
So we've been working on looking into stat.json improvements, and let me share the screen.
Okay, let me stop then.
Oh, so many screens. Can you guys see my screen?
Yep.
Okay. So we've been looking into the stat.json, and briefly there are two problems with the stat.json. First, what people usually think when we say stat.json is they say the stat.json is slow, which means it takes time to get response from stat.json, which means the Mesos UI is slow, and some other tools like DCOS UI until version, I think, 1.11 is also slow. However, there is another problem which probably has a higher priority, is the isolation problem, that Step.json impacts the overall performance of the master actor, which means in very unfortunate scenarios, malicious actor can spend 90% of its time just crunching data for Step.json. So there are several aspects of this problem, especially if we talk about how to improve, especially if we look at the core of the problem, like delivering state information to consumers. The answer to slow Step.json might be to use v1 subscribe endpoint that will this will give you the first fix of the cluster state, and then it will give you an update. However, we still want to tackle the isolation problem first, and this is right now our first goal. So we did some tests in order to gather some data. The first was we did some tests internally. The first was a smaller cluster with 22 agents and around 390 frameworks. And that the time spent is a lie. Don't look at that part. And we got this data. So we see here that as the response size of the Step.json rises, the time the master actor spends in processing the Step.json requests grows, I would say, exponentially. The reason for this is that the time each subsequent Step.json requests needs to be answered includes the waiting time of the queue, which includes the time that all the previous Step.json requests that have been sitting in the Q1 request has arrived took to be processed. And these, if you look at the bottom picture, the blue lines, these echoes, this is exactly the amount of wait of time that a specific request was, like, how can I put it? It's the number of requests that have been processed before a request that is depicted has been answered. So,
hey Alex, can you just kind of explain, like, overall what we're looking at here, like what the gray is and so on?
Sure. So the gray is the total time for a Step.json request to be answered, so measured, let's say, from a client perspective. The red dot is the time that a specific request, Step.json request, spends in the master queue until it is scheduled for processing. And the crunching here is the time that the time it takes for request from being processed first to the time it was handed over to the process to be sent to the client. The crunching is a little bit confusing, the blue points, because they include the time, they include an extra trip through the master queue due to authorization, that we do an extra dispatch, and it obviously hence includes the time that previous Step.json requests are processed, take to process. However, it also demonstrates, this echo demonstrates how many requests are sitting in the queue when this specific request arrives.
So does that mean you have requests being submitted frequently enough so it sounds like they're affecting one another, the times of...
This is correct. This is correct. And this is one of the first problems we try to seek to fix, the exacerbation, which means the more Step.json requests you send, you pretty much, it is an effective DDoS attack. Yes.
Hey Alex, so the red says queued.
Yes.
And the gray is waiting in the queue, or
the gray is the total time.
Okay. Oh, I see.
From the client perspective.
Got it.
And we see that the total and the
blue included that second authorization in queuing.
This is correct, and that's why we see echo. because the blue includes that one extra dispatch after authorization, and that's where we see that the blue times differ, and they are multiple of a specific number, let's say 800 milliseconds. That's because of this extra trip through the master mailbox. So this is a little bit confusing. This image is a little bit confusing.
Yeah, I guess
Questions?
I still don't understand exactly why we would see 2x or 3x the time required for authorization in a given request.
Yes. So for each stat.json request, let's say before stat.json requests is actually processed. For actually processed, I means we take the master state and let JSONify convert the master state into the JSON string. The request travels through the master mailbox twice. The first is when the request is put for the first time, then it's being processed by the master, and the master schedules it onto authorizer, and once authorizer creates all the object approvers and another authorizing stuff, the request is being dispatched for the second time. And due to this fact, due to this two trips through the master mailbox, in this processing time in which we include this second dispatch, we see the time of all previous state requests that have been dispatched into the same master queue is included into processing. I'm not sure, Greg. It is now.
I can help. I can help put it another way if
Please do, Ben. Yes.
So in order to process a state.json request, you have to get authorized. That authorization result is also processed on the master through a dispatch. So when I time how long it takes for my state.json to get processed, I have to do another trip through the queue. I already did a trip through the queue to get on to start my timer. I have to do another one once authorization is processed. In that second one, another state.json could be finishing its continuation, which would impose like all that extra crunching time on our current request. Does that make sense? I thought I would do that more eloquently, but I didn't.
No, it's all good. I think that makes sense. So is it the case that for any given request in this plot, there's only a single blue dot?
Yes, this is correct.
Okay, yeah, I think I understand.
Yeah, so it is unfortunate that we include waiting time in the queue. The second time we pass through the master queue, we include into crunching. So it's a nice picture, I think, because it gives a very good intuition about what has happened, that the processing time is actually the multiple of the, it's actually some time for processing a single request multiplied by the number of requests sitting in the queue. So we have a second test on a bigger cluster with more than 100 nodes. Yes.
So how do we, so in this graph, how do we know how much time was spent in actual crunching versus how much was spent in the queue?
This is the lower line. So the lower line is how much time you spend per one request. And these echoes are definitely multiples of this.
The lower line.
Yeah, the lower blue line.
Okay.
That's for single request, obviously. And echoes are when the request times multiplied. Yeah, when there have been other state requests in the queue.
Oh, you're saying this, the bottom line is when there were no other state requests in the queue?
That's correct.
Okay, and the one above is if there was one more, and above is there two or something
Correct.
like that?
This is correct.
I see.
There are 6 lines. You almost don't see the 6th, but I know it's there.
I only see 4.
There are 6, yes.
Okay, I see. So there's a subset of them which did not have anything in the queue with respect to state as far as
Yes.
their whole processing is concerned.
Yes.
I see. Okay, got it. And from this, did you get some numbers on what exactly or what roughly would be the just the crunching?
Yeah, it's the lower line. So up to 1 second.
Oh, I see. I see. So why does it vary quite a bit? Like from close to 0 to 1?
Close to 0. No, there is no 0. So crunching is 1 second.
Yeah,
So
I guess,
after some period of time, or what's the question?
yeah, I guess before, like at the 1, I don't know how many zeros are there. At that point, the time to crunch seems to be very low. Why
I
does
see.
that change?
I see. The graph above shows you the response size in kilobytes. So
It's basically the response size has been changing over time. Got it.
exactly. So that was a real cluster. We've been running workloads, and something all is 3 and a lot of zeros. A lot of workloads were started on the cluster, and there were more frameworks, more tasks. I don't have this data included here. We can map it, but I think
I see. So you're saying if we actually normalize it, it would be very flat.
Yes. You mean normalized by response size?
Yeah.
Yeah, pretty much.
Okay.
That's how it feels to me. Yes.
I see. Okay.
Okay. Shall we move on?
Fine for me.
Okay. So the second test was a bigger cluster with more than 100 nodes, 12,000 tasks, and more than 1,000 frameworks. And we'll come back to this slide. Here the graph is slightly different. So what we measured here was the time that the request spends in the queue, including authorizing and including two walks through the master queue. Then the red that is almost invisible here is crunching, and I'll explain why crunching is 0. And the blue is the time we spent to serialize the response. And the blue is depicted twice on the lower graph, once on top of gray and once separately, so that we can see the pure serializing time as well as serializing time put on top of the gray on the waiting time. So first, why crunching is 0 is because in V0 standard JSON response, there is no crunching. All the filtering, there are no intermediate objects anymore. There is no filtering. Everything is embedded into serializing process. So JSONify library creates a bunch of proxy objects, and during the moment when we generate the string, we do the filtering from the master state directly. So the pure crunching time in V0 is actually serializing time of the master state into JSON string. Okay?
Mm-hmm.
Now, on the cluster that we've been testing, only V0 state.json was used. So V1 get state and V1 subscribe, where this assumption is not true, where we actually have crunching, where we convert the master state into intermediate protobuf that we then serialize. No clients, no tools were using these endpoints, so there is no data here for this. Now, if you look at the time spent per request, so from the total time, 39% on average across all stat.json requests across the lifetime of the cluster were spent in waiting. 30% of time were spent waiting for the second time in the queue, plus waiting for the authorizer response. And for serializing was spent again 30%.
So how do you calculate the percentage? Is it also normalized per? For the request size, response size?
No, it's just total across all the requests. So I simply summed up all the times across all the requests.
Okay. So it's not like if this request took 5 seconds and inside this, I guess that's fine.
Think about it as a ratio of integrals on the image below. We take the if you calculate the area of the gray and blue, so that ugly figure, if you take that area and if you, for example, take only the serializing, so the area below the serializing line, the dotted blue line, and then divide one onto another, you will get what I'm talking about.
Okay, it's total wait time divided by total
Correct.
response time.
Correct. Across all requests.
I see. And authorizing is 30% probably because that's a lot of it is coming from the waiting.
It's not probably. It includes the second trip through the master queue.
Second trip. So I guess roughly half of that is, or like 39% is waiting. Let's say 40. So 20% is actually can be accounted to the trip. So only 10% is actual authorization.
I think even less.
Okay.
But I don't have these numbers. No.
Okay. And serializing is 31%. Okay.
Yes. So the plan going forward is there are several things that we plan to do in the nearest future. So the first one, we would like to calculate the cost of creating a deep copy of the master state. I will explain right now why we're interested in this at all. The second would be to pool state requests together and process them in parallel. And the idea behind this approach is that if we observe at a certain point of time, we observe, let's say, 6 state requests in the master queue, we will dispatch an internal response, let's say respond all state requests call onto the master queue at the moment when we observe the first request, and then until we reach that dispatch in the master mailbox, we accumulate all 6 requests, and then we block the master actor, we spin up 6 worker threads and respond to 6 requests in parallel. So ideally, because we don't need to modify the master state to respond to standard JSON requests, we only need as a read only. We can reply all the state requests in parallel and save time and save time that the master spends answering them, as when it in comparison that the master would have answered them individually. So the idea was suggested by Ben Mahler. So we're going to try the polling. The drawback here might be that if master queue is long and we have a lot of state requests sitting in there, when we gather them and we are about to process them, let's say we have 30 or 40 requests to answer, then spinning up 40 worker threads and blocking the master actor until all they finish might not give us a 40x speed up. So it might take still more time than we spend processing one single request. So this is why we would like to estimate the cost of creating a deep copy of a master state, because an additional or alternative, but probably additional approach would be, instead of trying to respond these pooled state requests in parallel, we can create a deep copy of the master state, let the master continue doing its job and answer all the pulled requests either together or one by one, it doesn't matter, in a separate actor or on a separate thread. However, it makes sense only if creating a deep copy is way cheaper than answering one single request. So we would like to get a better idea how expensive will it be. Then obviously to get some numbers how we improve, we would like to add a benchmark to somehow measure the master actor load so that we can see that, okay, with this approach, we reduce the master actor load by, let's say, 30 or 40%. And an extra, sounds like a very easy improvement, would be to avoid the first trip through the master queue when we need to get authorization, and do not send the authorization through the master queue, but onto a separate actor that has a shorter queue. There is another suggestion came recently from Ben Mahler, but I think Ben will talk about it separately. I think I'm done. And are there any questions?
That was really great, Alex. Thanks a lot for presenting. Do folks have questions?
I was just wondering if you guys had considered, so along the lines of making a quote-unquote deep copy of the master state, I was wondering if you guys had considered the possibility of incrementally pushing updates to a copy of the master state in batches or something to avoid like a big one-time cost of the copy.
Yeah, I think it's a very good question, Greg. We even have, that's how V1 get state or subscribe works. So we send a first fix and then we send updates. However, it sounds like a non-trivial and definitely not a very easy task to incorporate those updates. So pretty much, let's say we need specific structures in order to answer each stat.json request. They are actually frameworks and slaves. And these structures inside, they contain all kind of, a lot of different collections. Now, each time when the master updates anything in those collections, we should issue an update to the separate actor. And I think just finding all those places and make sure that we modify the next time anyone modifies the internal state of the master that we need for the to respond to state requests, that next time the person modifies that state, they remember that they need to send an update or it should happen automatically. It's definitely not a trivial task. So I would say the global idea that we probably at this time agree upon is that we should move off from V0 state.json to V1 get state and subscribe. However, because there are a lot of people using stat.json and V1 get state and subscribe calls are not very well tested yet, we decided to go for smaller improvements first and then think about sending updates later and probably move into this to V1 API later. Does it answer the question, Greg?
Yeah, it does. Thanks, Alex.
Sure.
Any other questions? Alex, can I get you to post those slides on here if you're open to sharing them?
Yes, of course.
All right. Thanks again, Alex. Really appreciate it.
Yeah, that was great.
The next thing that Alex was alluding to was I was looking into RapidJSON, And the idea here was to take, that is not what I expected. No, confirm. The idea was to take JSONify and preserve the interface. So, you have these writers here, Boolean writer, number writer, and so on. Right now, these things do the serialization, right? This writes like true or false to a stream. This writes, knows how to write a number. The string writer does something which is wrong, but it, tries to write a string. The array writer writes an array, and so on. So I want to preserve these interfaces because that's actually what the callers use. They'll call like element here. But I wanted to change the implementation to use rapid JSON writer to write the data. So I prototyped that yesterday, and I took some numbers. This is from the master state query benchmark. What it does is it spins up a bunch of synthetic agents with tasks and has them register with the master, and then it issues a state query. It does a V0 state query, a V1 state protobuf query, and I think of some other variants of that with like maybe converting to JSON and so on. But the baseline here is V0 state. And this is like a box plot where the lower end here's the minimum. The bottom of the box is the 25th percentile, so the first quartile. Then the top of the box is the third quartile, so the 75th percentile, and then the top is the maximum measurement. So with rapid JSON, it looks like we cut time almost in half, around in half, I would say. And this is with the default settings. I also tried turning on the single instruction, multiple data options, but it looks like that actually is a little more inconsistent and maybe a little slower. There's actually not a ton of those instructions that are used in the writer path. There's just one spot that they're used. Those are probably more useful in the parsing path, and this is the serializing path. So it didn't make much of an impact here. It kind of looks like it might actually slow it down a little bit. But it looks like this does provide a quick, short-term, easy improvement. So I'm going to try to get the patches out to update JSONify to use rapid JSON, and hopefully that'll make things better for users in the short term.
Hey Ben, did you
Yep.
look into the licensing of rapid JSON?
It's a good question. I didn't.
I'm looking at the license file, and I guess there's some MIT, some BSD, which I think is compatible with Apache license, but the JSON license, specifically the used for good part, I'm not sure about.
This here?
Yeah, that might have compatibility problems. I think ASF has a page which captures the Apache 2 license compatibility matrix.
Okay. Is this something that's like, is this JSON license a thing, or is it just for this project you happen to know?
The JSON license is like a thing. So it seems like they are importing code that's licensed under that. Oh, there we go.
So apparently the JSON, yes, is a problem.
So it might. So I don't know. I guess maybe we get lucky and the part that's licensed under the JSON license isn't required or something.
Okay.
It looks like they've pulled in some code from a bunch of other projects.
Is that why it's here there?
I guess so. So other dependencies and license. So if you scroll back up a little bit, there's a heading other dependencies and licenses. So they might be things that you'll pull in as side effects of this. I'm not sure.
It might be this JSON checker thing. Like maybe it's their tests.
Yeah, if it's tests, I guess it's probably all fine, but it probably needs a little bit of checking into. That's all.
Okay. Yeah, it looks like RapidJSON libraries. RapidJSON source code is licensed under MIT license, except for the third-party components listed below, which are subject to different. To avoid the problem of JSON licensing on projects, it's sufficient to include the bin JSON checker directory. Okay, great. I'll look into that and make sure we do that properly. Thanks, James.
Do you need help to spin up patches or reviews or anything else? I will gladly help.
At this point, I did the integration. I didn't run all the tests. I ran the stout and lib process tests and found that we have we have tests that like verify we do the wrong thing. They have like they have invalid UTF-8, and they're expecting something to happen a certain way. We right now don't have any way to surface errors during JSONification. The library doesn't provide any error return mechanisms. You could like throw an exception or something, but right now we just ignore any errors. So that's kind of what I did with my patch. RapidJSON has a mode where they don't validate UTF-8. I think the only impact this has on us is the files endpoint, where we will sometimes spit out binary data if people are trying to look at log files. In the past, there were some issues around like actual Unicode characters because we don't do it properly, but this would fix that part of it.
I think the same issue is with the processor's endpoint too.
Oh, okay. Yeah, so like what this does is it will do the right thing for UTF-8. If it's not UTF-8, it'll do something which puts, I don't know if it's doing the right thing, but it's doing something. We're also doing the wrong thing, so it's kind of hard to compare the approaches. But that's where I think I'm not sure yet to what degree I'll have to change things or just adjust tests and so on. But other than that, I pretty much, the integration's done. Yeah, I would just, I'll obviously need reviews. So whoever wants to help with that would be great.
Sure, reviews gladly, and even if you need help with adjusting tests or looking into the errors and how we can now start propagating them properly, I can even help with this, or ask Benna to help.
Yeah. Okay. Yeah, I think with this, along with the single dispatch change, we should have a pretty substantial improvement for users. Like if we compared those graphs that you had to what it would look like with, things taking half the time in the queue as well as half the time serializing, it should help us get a little bit more headroom. So I don't know if you were interested in working on that next, but it would be great to have that as well. Alex?
Yes, sorry. You were saying that
I was just saying, I think with this rapid JSON change, and if we were also able to get the single trip through the queue changed with authorization, we should have a pretty nice improvement for users.
Yeah, it will be the first step. We still don't solve the isolation problem, which means
Right.
if you send sufficient std.json requests, then you DDoS the cluster. But yeah, definitely, those will be very, very good and valuable improvements.
Yeah. Okay, so hopefully we can get this all in 1.7. I think it's mid-August or early August.
I hope so, yes.
Does anyone
I would
know
love
when
to.
1.7 is?
There is no date yet, as far as I know. There is not even a release manager yet.
According to the quarterly schedule, it should be mid-August timeframe.
Okay. So I'm really hoping we can get the rapid JSON changes in by then, which I think is for sure, and then also the fixing the double dispatch as well.
Yeah, I would love to. I would even love to have the pooling done by 1.7. So if you need any help with rapid JSON, please let me know. I'm very keen on pushing this.
Great. Okay, we have only 12 minutes left, so I don't know if we're going to get through all this, but maybe I'll just call this actually, how should I do this? So I'll just mention a few briefer things that we don't have any slides or anything interesting to show for. The first was our JSON parsing. So this actually did conversion. So first of all, we don't really use this in a lot of performance critical places. The master does use it in some endpoints, like if an operator posts JSON or a scheduler posts JSON, then we do JSON parsing. Not a lot of users, it's not a high load generally from what users are doing today, but I did notice when I was writing a test that the conversion cost is essentially doubling the time it takes to parse. So it's cut in half now after that fix, but probably also this could benefit from rapid JSON. I'm not planning to look into that soon, but it's definitely something we could look at if this ever becomes a performance issue. I'll mention this other one, which is Greg and I have been making some improvements to metric scalability in libprocess. This is mainly in support of per framework metrics. So there were some pathological performance issues where like we were doing an STD list size, which was still n squared, which was still order n on in some standard libraries. So we fixed all that, and I could show numbers if we have time, but I don't think we'll have time. So I'll just punt on showing anything for that right now. The next thing to mention is there's been some various allocator performance work. I think the short of it, and please correct me if I'm wrong, Meng, but I think the short of it is that in our scale test that we were doing, we saw the allocation round time go from, I think, 15 seconds to 3 seconds, something like that.
5 seconds.
5 seconds. Okay, so something like 15 seconds to 5 seconds. And after gathering more perf data, there's still some really obvious improvements to make. So we're thinking we can get that much lower. So some pretty substantial performance improvements are being done to the allocator, and I'll make sure we have some data to show or a blog post or something. But right now I don't have anything nice to show for that. There's also some work being done to expose some metrics in the process for the event queues, as well as endpoints. I don't know if there's any patches at this point, but I asked Ben to include a few folks that have been interested in it, Greg and Gaston. I don't know if, James, you want to be on those reviews as well or not, but if you do, just let me know. I can ask Ben to include you.
Okay, I'm probably interested in keeping an eye on it. I don't know if I'll have much time to do a reasonable review.
Okay. The last thing, or the last two things, so Dario's on the call. I don't know if, Dario, you want to chat about this briefly, or if you have any interesting numbers to share, but there was a additional queue added recently, specialized to be multi-producer, single consumer, which is our use case for, I think, event consumption, right?
Yes. So the reason this has been added is, I mean, there has been some work ongoing with getting log-free queues into the process, and the original queue that was used there has, I mean, it is really fast. The problem with it is that it does not guarantee the order of the elements to be the same when dequeuing that it was when enqueuing. So, I mean, it guarantees that per thread. So if you send a message from one thread, it's guaranteed, or two messages from one thread, they're guaranteed to be in order when they're being dequeued. But since in the process, a process can move from one thread to another very quickly, the messages could be out of order from within that actor context, which is a huge problem. To fix that, there was a sequence number added, and so reordering had to be done on dequeuing the messages, which obviously killed some of the performance of the queue overall. So I came up with this MPFC queue. It is heavily inspired by implementations in JC tools, and there's a blog post on 1024 Cores about a queue like that. It's a linked queue structure, and it guarantees the ordering. It's I think it should, yeah, it's linearizable. It is mostly weight free, and I can share some numbers. So on my machine, I'm working on a MacBook, 4 cores, 8 threads, I think 2.5 gigahertz. I'm getting on a contended with using 7 threads to produce 1 to consume, obviously, because it's single consumer. I get a total throughput of around 54 million messages a second, or operations a second. That is around 38 million inserts and 15 million DQs. Anything else that would be interesting here? I have some slight optimizations in flight that especially improve non-contended DQs and also DQ on an empty queue, which I mean is not a very interesting case. It's just a side effect, but it would improve DQ on an empty queue by an order of magnitude. But also DQing a non-contended queue, so if there are no producers running at the moment, would also improve throughput slightly, not quite as much, but.
Hey, so, do you have any idea what the baseline throughput is without the lock-free queue?
It is somewhat hard to measure. I mean, I could run the actual like the process throughput tests. I think I've done that in the past, and I think my implementation was about twice as fast. So the throughput was twice as high as the current non-blocking or lock-free queue implementation. But I can run some more benchmarks and see how much better it would be. But the queue itself, as I said, it is hard to test that because of the reordering that is done in the current implementation or in the previous implementation that is not done anymore in this implementation. So.
So is this behind a configure time flag? We want to turn that on.
So the event queue, if you use the concurrent queue flag, would now always be MPSC.
Oh, okay.
You can still use the blocking queue implementation or the non-lock-free queue implementation if you do not set the flag. But if you use the concurrent queue, it will always be this one.
Okay. Great. I'll try to get those throughput benchmarks run so that maybe we can come up with a blog post to show the improvements and hopefully compare it to, I think Ben based that benchmark originally on Scala, so hopefully we can compare it in a positive light to Scala's performance.
So both of these are all, I guess the original lock-free queue was a build time flag then? You can't switch it at runtime?
No.
Yes, that's correct.
Is there some fundamental issue with, is there something fundamental that prevents that, or is it just that people didn't think it was worthwhile at the time?
I think it's just the current design. There's nothing that would prevent us from doing it at runtime. I mean, obviously, if you use a fixed implementation, there's potential for better compile optimizations, but I think that's the only thing. Like no virtual calls or anything like that, right?
Yeah, that was the only concern at the time. If it turns out that we want to actually have multiple queues and you can select from them depending on like if I'm a low overhead situation or if I'm like a high throughput situation or whatever, then probably we have to have the runtime option. But I think the original thinking was that we would eventually get towards having this queue be the default and not necessarily having the other options. But maybe that's not how we should do it. I'm not sure.
That probably makes sense. I mean, it doesn't sound like having a runtime option makes it way easier to test, but it doesn't sound like something that we really would like want to teach people how to configure.
Yeah. Okay, with 1 minute left, there's lots of content for the next blog post. If anyone's interested in writing one, let me know and I can assist. Otherwise, I'll probably try to figure out how to get some of these into blog posts, either like one mega one with subsections of like what's in 1.7, or maybe just kind of do it piecemeal. And I'll reach out to people for help with that. But definitely let me know if anyone's interested. And I can help you with that. All right, we're out of time. Thanks for joining. Hopefully this was an interesting one.
Thanks, guys.
Thanks, Ben.
Yep.
Thanks. See ya.
See ya.